So, like I said, the basics of the stuff we were looking at yesterday was pretty straightforward. Where you had your A, H, and K, or you had your the ABC with the with the X values on top and bottom. Now what happens is we're going to start expanding our graphing into stuff with different degrees. And we have to look at how the degrees work out and how the setups. There are a ton of rules for this. And I have changed it to make it look a lot more user-friendly. What happens here is that if you're dealing with your polynomials again, P of x divided by Q of x, there are following rules. And I'll explain all of this with some examples here throughout this. These are your rules. And this is for graphing P of x over Q of x. Remember, where P and Q are both functions. Yeah, this is something you're going to have to know. So what happens here are basically these three things. The rules that happen here is that you're going to have possible x-intercepts. Your x-intercepts are always going to be the zeros of the numerator, which means, again, we'll probably have to factor. The vertical asymptotes are going to be the zeros of the denominator. Again, we're probably going to have to factor. And then horizontal asymptotes can occur at three possible variations. These m and n's are going to be what they call the degrees of the polynomial, and that's what I kind of brought to the side here. And I'll let you guys write this up, and I'll start to show you some examples here.
Should we just write out the three that you put, or should we write out the bottom and stuff?
I would just write out what's on here for right now, just because that way we can get them all going. Because those are the three that you're going to see. I'm trying to I'm just going to kind of walk you through a simplistic idea here. And I'll walk you through the example I put up on the whiteboard here, just as a generic idea. We're not going to graph it, we're just going to walk through how you get intercepts, how you get zeros, and things of that nature. I tried to type this one in on this last value here where the m equals n. Remember, the m and n are the degrees of the polynomial. The way that you're able to tell the degree of a polynomial, it's always the highest exponent, the highest positive exponent you have. This is y equals a over b. This a and b are the coefficients of the highest degree. So if I walk through the example that I have right here, if I use 2x minus 1 over x squared plus 7x plus 10, and I'm going to start by labeling out all the different parts of that graph that we're going to go with. Can I put this on? Can I clear the screen and do those parts? All right. And after we do a few of these, it becomes pretty straightforward. Yeah. Isn't that how you spell zeros? No. Is there an E in it? You didn't know.
I don't know. There's an E in zeros.
I had a 50-50 chance of being right.
I think it's ES.
I don't know.
Because heroes is spelled ES.
I think it's just we should
I think it's ES.
Go ahead, you got one.
Isn't it ES?
got stolen.
I think it's ES.
I'm Googling this.
No.
Well, all right. Since we're all gonna freak out because my spelling is horrible.
Wait, you put one,
It's just
so you didn't put an E on the first.
Is it just OS? Okay, there it is. Zeros.
What?
Zeros, right? You know what you guys can do about it?
So
Thanks, Bomber.
Why does heroes have an ES?
I don't know.
Oh, it has OES. It has an E.
Silly
My phone says OES. I Googled it.
I just copied that first.
Is it?
Again. So let's take a look at how this sets through. When you have when you have a setup where they're going to give you an idea to graph, you always start these things kind of the same way. You're always going to start by labeling out all the parts that you can find. If I'm looking at 2x minus 1 over x squared plus 7x plus 10, I start with the first question. Does this have any x-intercepts? Well, in this case, it has an x-intercept, and the reason it does is because there's a value of x in the numerator. Where is the x-intercept for that problem? It's at 1/2. So I know my x-intercept is at 1/2. Just basically solve it for 0. Okay. It's the 0 of the numerator. So I set the numerator equal to 0 to figure out what it is. Okay. And vertical asymptotes. The vertical asymptotes are going to be at the zeros of the denominator. So my vertical asymptote here is going to be at the zeros of, well, if I factor it, what do I get?
X plus 5 and X plus
Good. I get x plus 5 and x plus 2. So my vertical asymptotes will be where and where? Good. So it'll be at x equals -5 and x equals -2. Now I start to go into the where will I have a horizontal asymptote. This is when I have to look at the degrees of the polynomials. In this instance, in this example, what's the degree of the numerator? What's the degree? It's 1. It's 1. What's the degree of the denominator? 2. So which of the three cases do we have to use? Is the degree smaller than the denominator? Is it bigger than the denominator? Or is it equal? Smaller, right? In this case here, m is 1, n is 2, 1 is less than 2. So it's case A. So where is my horizontal asymptote? At 0. So my horizontal asymptote is at y equals 0. Okay? So now we have an idea of what this graph starts to look like. If I have an idea of what this starts to look like. When I get into that, if I know that I have an x-intercept at 1/2, what should I put there? Dot.
It's not an S.
Not an asymptote, you're right. If I know I have an asymptote at -5 and -2, what should I do? Draw some dotted lines. And then I have a horizontal asymptote where?
0.
It's 0. So I draw another dotted line. And sometimes it's tough to draw a dotted line through the for y equals 0. If you want to sometimes if you want to point at it and say it's dotted on the axis, that's fine. So basically what we have done is we have created 2 vertical uprights and a horizontal upright. We've created basically 1, 2, 3, 4, 5, 6 parts of a graph area. Everybody see that? Yeah.
How'd you get the y equals 0?
Again, in order to figure that out, we had those 3 different cases. depending upon the degree of each the numerator or the denominator. If the degree was smaller than the degree of the denominator, your asymptote's at y equals 0. If the degree was equal, then you had the coefficients, the y equals the fractional of the coefficients. If the degree of the numerator is bigger than the denominator, then there's no horizontal asymptote. That's what we're looking at. That's where that came from. So again, as we get into this then, we need to figure out how to plot the graphs. You know where your asymptotes are. What did we do yesterday? We just pick points. What do you think you do today? You pick points. You pick points. Again, the easiest thing to do is just to start at somewhere. I'll start at maybe -6. Find an ordered pair with -6. Find an ordered pair with -7, because those are the next two over here. I have two values in between the uprights. Do you agree? Pick a couple of those. -4, -3. And then I've got points on the other side. I know I'm going to go through the x-axis with 1 point, so maybe I'll use something that's very easy to work with. 0, 1. What we're doing here then is just picking points. Getting a rough idea of what it's going to look like. It's a rough sketch. Will some of these points be god-awful looking fractions? Yeah. It's completely, totally possible. It's just a matter of being able to do order of operations then in your calculator. Okay? So let's do this. You guys do 6, 7, -6, -7. You guys do the -4, -3. You guys do 0 and 1. Woo! All right? And we'll just try and substitute in our values and see what we get. We'll try that out. And remember, your fractions are probably going to be ugly. Pause when we put this in. So this is weird looking. Very ugly. It is pretty, isn't it? Yeah. So we have -13 over 4 is what? 3 and change? And that's at 1.5. I can do that one. So it's curving like this. Then you had another one where it was at 4 and what was that? 4.5. But if you remember the graph on that one, wasn't it doing this? And then the other one at 0 and negative change, this one was coming up like this, but you don't see it's just tailing off here.
Is it incidentally getting smaller?
Yeah, it comes peaks and over. What's that?
What are the points for 0 and 1?
0 and 1 were negative. I got -1/10 and 1/18. But if you look at the way that it's going, it comes up and just continues out this way. Now, granted, ladies and gentlemen, this is a nasty graph. But the legwork that you had to be able to do was to do the setup. Identify all of this stuff. The rest of it you can get from a table. Yeah.
Why is that middle one flat?
The way that it works when you have these weird looking function stuff, the way that it has all these changes. When you have the different asymptotes, it allows you to have different changes within the graph. So you're going to start to see patterns at that. It's just a weird graph. Plus it's parabola because if you look at what's the degree of the one of the denominator? It's got a square term in it, so you're going to always have some parabola in that square. All right, it's just kind of a weird setup and how that goes. Yeah.
So when you're saying that you can just get all the other stuff from the table, does that mean I'm testing this?
Probably, because you can't really do this with by hand. You can't. I'm not going to have you guys look. Can you imagine the fractions you have to get? Yeah. Yes, sir.
I don't really understand how it touches the aspect.
It doesn't touch the asymptotes. It gets infinitely closer to it.
But what about the x-intercept?
Oh. I wonder if I made this weird because of the way that it works.
See, I got something where it touches the
Yeah, you're right. I wonder if it's because I just made it up. Let's look at the one that I have pre-ready. Let's try another one.
Wait, Mr. Murphy, I like that one.
Yes, sir.
Okay, in the table at -5 and -2.
Uh-huh. See how it says error?
Yeah.
That's
that
your
means
asymptote.
you don't touch it, and that's right.
Yep. Let's do another one here. Let's try this one. It might be a little bit cleaner then. So we have 4 over x squared plus 1. Do we have an x-intercept here?
No.
No, there's no x-intercept. And why is that?
Because there's no x in the numerator.
Good. So there's none. There's no x-intercept. Vertical asymptote. Square root of -1. Can I graph that? So is there any vertical asymptotes? There's no real asymptotes here, so there's none.
I like this.
All right. Again, the degrees here, excuse me, the degree of the numerator is less than the degree of the denominator. Yeah.
I'm just looking at the last one.
Okay.
And the x-intercept is 1/2, but then you line on the y-intercept, which is the asymptote.
I made up the problem off the top of my head. I think that there was a problem in that. I wanted just to show you guys how you pluck the parts out. I should never make things up off the top of my head. In this one, do we? What's my horizontal asymptote, or do I have one? The horizontal asymptote is going to be at y equals 0. Okay. I know that again because the degree of the numerator is smaller than the degree of the denominator. So they have those 3 rules you have to go back and look at. So now, again,
-√3 maybe? No, -√5.
what are you talking about?
Where to get a 0?
No?
0 is you get. Oh, wait, no. There's no horizontal either.
The degree is 0 over 2. So yeah, your degree of the denominator is larger. So that means you have a horizontal asymptote at 0. Because of the rule, the 3 rules.
What does the M stand for?
Degree of the numerator.
Oh, okay.
So now if I look at the table, you'll notice at 0 it's 4. At -1 it's 2. At 1 it's 2, but it's doing this.
What the heck is that?
A weird graph.
I like it.
Sure.
How
Okay.
did you know which point?
Now, what's my domain? Are there any restrictions on my x values?
No.
Nope. Domain is all real.
The range has to be constant.
The range is going to be
Anything above 0?
greater than 0. Because it's not going to equal 0. It's just greater than 0. So there's your domain and range. What's up?
What points did you use? For
I used my table. My table gave me easy points to work with. It's 0, 4, -1, 2, and 1, 2. The rest of it just tails. You watch the fraction amount, it just tails itself out.
Symmetrical, right, on the x-axis.
So we have another axis of symmetry, like if we were just graphing a different parabola?
Yeah. Yep. Let's do another one.
I like it.
Okay, oops. Y equals 3x squared over x squared minus 4. X-intercept. Careful. Careful. 0. My x-intercept, take the numerator and set it equal to 0. What does x have to be? 0. So my x-intercept is 0. I know that. My y-intercepts, or excuse me, not my y-intercepts, my vertical asymptotes would be, well, x squared minus 4, set that equal to 0, and plus or minus 2. What's that? 0 of numerator. Vertical asymptotes are zeros at the denominator, so I know that they're going to be at x equals plus or minus 2. Just because you don't like graphing doesn't mean you throw your pen at me. Now, horizontal asymptote.
No.
No horizontal asymptote? Why is that?
No, it's A over B.
So is it 3?
Okay. So your degree of your numerator equals the degree of the denominator. Oops. In this case, it is 3. Oh, sorry. X. It's squared equals squared. So that means my degree of my horizontal asymptote is going to be at y equals 3 over 1. The reason it's 3 over 1 again is because I'm looking at the coefficients of the leading term. Okay. So I have a horizontal asymptote at y equals 3. And again, we've kind of blocked ourselves off into those 6 looking things. What can I do now? Don't cry. It's just math.
Math is hard.
Gotta find some points. Go to your table again. You want to always want to label out 2 points on either side. Let me put a separate sheet here so we can write them out. When I go to my table, I'm just using the table here. I know that I have negative 4, 4. I'm trying to see if there's another clean one. Not really. So negative 3. 27 over 5 is what? 5 and change? 5 and 2/5. So negative 4 and 4. Then negative 3, 5 and 2/5. So it's doing this. Between, yeah.
How do you get 2 equals 2?
I'm looking at the degree. The degree of the numerator is 2, the m value, and the degree of the denominator is 2. That's where I was getting the m value. Look at the sets between. I have negative 1, negative 1. We know it's at 0, 0, and then 1, negative 1. So you'll be able to tell that it's making the another parabola here. And then on the opposite side, 4 and 5 again, you'll notice they are symmetrical. It's on the split screen like this, it's tough to line everything up. Can't get that thing to look right. But that's what it's looking like. All I'm doing, again, identify zeros of numerator, vertical asymptotes, horizontal asymptote, That's the legwork. The rest of it is just substituting points. Oh, we're running short. Oh, well. We're going to be doing this for a couple of days, so it's not going to be that big of a deal. I think what we might do tonight is just have you guys not worry about graphing, but labeling everything out first, and then worry about the table stuff again. So let's try this last one here, and we'll call it quits on this, and then
There's no horizontal axis, no horizontal axis.
okay, so you guys are already telling me this. First thing we figure out is our x-intercepts. If I'm looking at my x-intercepts, I have to find the zeros of the numerator. So I have to factor what times what's -3 to get me to -2. -3 and +1. So my zeros would be at 3 and -1. Everybody okay with that?
Yep.
So that means my x-intercepts are at 3, -1. Next thing I worry about is my vertical asymptote is going to be where? Excellent. At x equals -4. I plot that. And lastly, do I have a horizontal asymptote?
No.
I don't have a horizontal asymptote because my m value is 2, my n value is 1, and when m is greater than n, there is none. That's using those three cases. Remember, m, degree of numerator, n, degree of denominator. From there, we can use tables, correct? We could. So what I want to do tonight then is I'm going to give you guys a few of these things to do this setup, to do just this generic part where you're labeling out what your x-intercepts are, what your vertical asymptotes are, what the m and n rule works out to be. If you're feeling rambunctious and you want to start plotting, plot a few of them with just like this. Plot your vertical asymptote, plot your zeros. We'll worry about creating the table stuff tomorrow. Does that sound all right?
Yeah.
Let's try that. I think the problems that I gave you guys should work out with that, even though not having to do all of it.
So you're labeling it? Just labeling, not drawing any graphs? So we want
Yeah,
to
let's
graph.
see here. Let's do that. Let's do this with, this is on page something. Let's do those 6 for right now. It's on page 551. I think that's good. Let's do these 6 on page 551. What I'd like you to do again is x-intercepts, what are they? Where are your vertical asymptotes, if you have them? What is your horizontal asymptote? If you want to start with plotting just those values on a graph, go ahead. From that, we'll build off of it more tomorrow.
Do we have to do it on the graph software, or do we do it on?
If you want to start by doing it by hand and then transfer it to graph paper tomorrow, that's not a big deal, because we'll use these examples in class to build our graphs, and that'll give you a couple more graphs and call it a day on it. How's that? All right.